Next is dimensions. Suppose we take a physical quantity, that is force, and its unit is kilogram meter per second square. We know force equal to mass into acceleration. M is mass, its unit is kilogram. This A is acceleration, its unit is meter per second square. We can represent this unit in terms of dimensions, and a formula is formed that is called the dimensional formula. If we represent this kilogram, because kilogram is the unit of mass, so this mass is represented by capital M. Meter is the unit of length, length is represented by capital L, and T is the unit of time, so we represent time with capital T. And put the power on it will be -2 and put in a square bracket. This formula is called dimensional formula. And these powers 1, 1 and -2 are called dimensions. That means dimension of mass is 1, dimension of length is 1, and dimension of time is -2. Here to write the dimensional formula, we will use letter M for mass, letter L for length, and letter T for time. And then we put a power as per the formula, say MA, LB, TC. These powers are the dimensions. And this whole is called dimensional formula. So we can say dimensions are the powers of base quantities. These M, L and T are the base quantities mechanics. And powers to these base quantities are called the dimensions. Now we see what are the uses of dimensions or dimensional formula. Uses of dimensional formula. Very important use of the dimensional formula are: number one, we can check the homogeneity of dimensions in an equation. That means in an equation, dimensions of a particular base quantity on left side should equal to the dimensions of the same base quantity on the right side. Then that formula will be homogenetically correct. If not, then formula will be wrong. Second is conversion of unit from one system to another system, in which this dimensional formula will be very much helpful. Third, deducing an expression. If we are given with the dependency of a variable on the others, then we can develop or deduce a relation. Now we will do some problems based on the dimensions. First problem is identify the pair of the equal dimensions. There are the 4 pairs given in this question, and we have to check which pair have the equal dimensions. To do such problems, we have to remember the formulae. Without knowing the formula, such type of the questions cannot be solved. So we have to memorize the formulas. First is torque and work. Torque is defined as R cross F. This is the formula of torque which we will discuss in rotational motion. From this formula we can say its unit is Newton meter. And work is W equal to F dot S. So its unit is also Newton meter. That means it has same dimension. Stress is defined as force per unit area. It means it has a unit of Newton per meter square. And energy is, say, kinetic energy formula is half mv square. Its unit is joule, and joule is Newton meter. That means these two units are different, so it is not the equal. Force and stress. Force is kilogram meter per second square, while the stress is, or we can say it is Newton, and stress is, as we have said above, it is Newton meter per meter square. So this unit is also not equal. Force and work. Force is Newton and work is Newton meter. This is also not equal. So correct option is A. Second question is identify the pair not having the equal dimension. Now it is opposite to the question number 1. Torque and work, we have already said torque is Newton meter, work is Newton meter. So these are equal. So these are equal. So as per the given question, this is the wrong answer. Momentum and Planck's constant. Momentum is defined as mass into velocity. That means its unit is kilogram meter per second. And Planck's constant h is E by nu. E is the energy, nu is the frequency. Energy is in joule, frequency is in per second. It means it is joule second. And we expand this. Joule has the expansion kilogram meter per second square, and it multiplied with second. It means we have unit kilogram meter square per second. And now we check the unit of momentum and Planck's constant. These are different. So this is also, this is the correct option as per the question, because we have to find the option which are having the not equal dimensions. Stress and Young modulus. Stress we have already given, it is Newton per meter square, and Young modulus is defined as stress oblique strain. Modulus of elasticity are stress oblique strain. Longitudinal stress and strain is the longitudinal strain. Stress is force by area. Strain is the fractional change in the length. Because length by length, so it is a unitless. Strain has no unit. And stress has the unit Newton per meter square. So we can say unit of Young modulus is also Newton per meter square. So stress and Young modulus will have same units. So as per given question, this is the wrong option. Speed and mu naught epsilon naught power minus 1 by 2. Speed has the unit meter per second. And mu naught epsilon naught power minus 1 by 2. Actually, we should remember the formula C equal to square root of 1 oblique square root of mu naught epsilon naught. Mu naught is the permeability of the free space, and epsilon naught is the permittivity of free space. And speed of light in vacuum is given by this formula. That means 1 by epsilon naught mu naught is the speed of light, and it also has the unit meter per second. So these dimensions are equal, and per question this is the wrong option. So our option B is correct as per the question.